Hey everyone, good evening or good afternoon, good morning, wherever you are. Thank you for joining this last session, last meetup of the year of the Continuous Testing Meetup, online, of course. We're very happy to have you here. We are gonna get started. First, I had to disable the annotations for others since I saw some people playing with that. So thanks for reminding me to do that. Cool. As is tradition, we're going to start with Oksana, and today she's going to share with us a Christmas quiz about all the knowledge she has shared during the year. So I hope you do well, because I have no clue how we'll do. So without further ado, Oksana, I'm sorry, please, the stage is yours.
Thank you, Diego. So I hope you can see my screen. So let's start. So I'm Oksana, and as always, we have 5-minute vocabulary session. But today, as Diego told, we are going to have a small Christmas quiz. So we have only 3 rules. So we have 7 questions, 40 seconds per question. It is also the name of a nightclub in Berlin, 40 seconds, and you have only one valid option, so no multiple choice questions. Just write your answer in the chat and compare it with other participants. So I will check my timer. So let's start with the first question. Which one of the following answers describes a test condition? A distinguishing characteristic of a component or system. B, a testable aspect of a component or system identified as a basis for testing. C, the degree to which a software product provides functions which meet states and implied needs when the software is used under specified conditions. And D, test cases designed to execute combinations of conditions and actions resulting from them. So I will start 40 seconds. Write your answer in the chat. Five, four, three, two, one. And the correct answer is B. So all other definitions A, C, and D, it is a different definition from ISTQB glossary, but not describes test condition. So let's move to the second question. In what way can testing be part of quality assurance? A, it ensures that requirements are detailed enough. B, testing reduces the risk of poor software quality. C, it ensures that standards in the organization are followed. And D, it measures the quality of software in terms of number of executed test cases. So 40 seconds starts. 5, 4, 3, 2, and the answer is B. Testing reduces the risk of poor software quality. So let's move to the next question. Which of the following activities is part of the main activity test analysis in the test process? A, identifying any required infrastructure and tools. B, creating test suites from test scripts. C, analyzing lessons learned for process improvement. And D, evaluating the test basis for testability. So 40 seconds starts. What do you think? Which of the following activities is part of the activity test analysis? 5, 4, 3, 2, 1. And the correct answer is D, evaluating the test basis for testability. So let's move to the next question, the question 4. Which of the following should not be a trigger for maintenance testing? A decision to test the maintainability of the software. B, decision to test the system after migration to a new operating platform. C, decision to test if achieved data is possible to be retrieved. And D, decision to test after hot fixes. So 40 seconds start. Please be careful. Which of the following should not be a trigger for maintenance testing? Five, 4, 3, 2, 1. And the answer is A, decision to test the maintainability of the software, because in this case, we speak about maintainability testing and not about maintenance testing. So the next question, so we have 3 questions left. Which of the following options are roles in a formal review? A, developer, moderator, review leader, reviewer, and tester. B, author, moderator, manager, reviewer, and developer. C, author, manager, review leader, reviewer, and designer. And D, author, moderator, review leader, reviewer, and scribe. So start. So these, the formal review and review roles, we discussed it, I think, some months ago, anyway, in this year.
Hello, everyone.
Hi.
Just making sure my sound was working fine.
We can hear you. You can write your answer. What do you think the right answer for this question 5 in the chat? Oh, so the time is already over, and the correct answer is D, order, moderator, review leader, reviewer, and scribe. So the question 6, which of the review types below is the best option to choose when the review must follow a formal process based on rules and checklist? A, informal review, B, technical review, C, inspection, and D, walkthrough. So 40 seconds starts. Five, 4, 3, 2, 1. And the correct answer is C, inspection. So are you ready for the last question for today? So question 7, which of the following statements about static testing are most true? A, static testing is a cheap way to detect and remove defects. B, static testing makes dynamic testing less challenging. C, static testing makes it possible to find runtime problems early in the life cycle. And D, when testing safety critical systems, static testing has less value because dynamic testing finds the defects better. So 40 seconds start. We also spoke about static testing and dynamic testing also this year, some months ago. You can find all videos in the continuous testing meetup group or continuoustesting.com. 5, 4, 3, 2, 1. And the correct answer is A. Static testing is a cheap way to detect and remove defects. So I hope you had a little bit fun and probably you learned something new. If you have any question to this short Christmas quiz, if you don't understand any answer, please feel free to write me now in the chat or contact me via LinkedIn or per mail. So thank you very much and bye-bye.
That was great. Thank you, Oksana. I think I didn't get like only a couple were correct. But I was always following what Aurélien was doing because he told me that he got the certification recently. So congratulations as well.
Yeah, last Friday. So I know this question very, very well.
Oh, 7 from 7.
6 on 7. I made one mistake.
All right. Well, thank you. Thank you for this. And this was just to get us warmed up. So let's follow on the main topic for today. Thank you, Oksana. Thank you, everyone, for participating. So let's move to the next one. All right. Yeah. Before jumping to the main topic today, we always like to thank our sponsors, Trending and Sauce Labs. So Trending in terms of testing consultancy, also the organizers of Agile Testing Days. If you need anything related to testing, please reach out to them. And Sauce Labs, one of the biggest vendors in testing, so all the stuff they do to help you do better testing. So reach out to them if you need help regarding that. And if you're curious about our previous events, please head to continuoustestingmeetup.com. The previous meetup we had about like 2 or 3 weeks ago with Lavina. The event's still there. We haven't uploaded the video, but this will happen soon. So when that is there, please feel free to check it out, to share with your friends, colleagues, and people who might be interested. And the bottom line of this is that all the events, all the information that you need about this meetup is happening in this website. So okay, somebody's visiting. My daughter is just entered the room, so yeah. Okay, this has never happened. Apologies. So before delaying it more, yeah, there she is. Anyway, I just want to say thank you to all of you for being here, our last presentation of the year. And it's a huge honor to have Andrew today, the Automation Panda, super well known in the testing community. I think we have had really huge names in the testing, in this testing meetup, but really, really huge names. Like we have had really important people, but Andy is one of the big ones in the testing community. So this is a big honor for us to have him here. And I hope you enjoy the talk he's going to share with us. The Screenplay Pattern, one of the 2 major, how can you call that, like paradigms maybe, like in UI testing, the page object one and the screenplay one. So I hope that he's going to give you enough arguments to take this one instead of the other one, or maybe ways to combine it. I don't know. Maybe you can send your questions his way. Also to congratulate him because he has recently joined Applitools. Also a great group of folks there, really nice people over there. I've met many of them. So really take advantage of his presence here today and enjoy this presentation. And if you have questions, please save them for the end, and Andy will be very happy to answer all of them for you. I won't make this longer. Andy, thank you for being here, and the stage is yours. I will stop sharing my screen.
Guten Abend, ich heiße Andreas und ich bin Automation Panda. Heute werde ich auf Screenplay sprechen. Well, hello, everyone. Thanks for attending my talk today. I'm super excited to speak here. Thank you, Diego, as well, for your very kind words. My name is Andy Knight, and you can call me Pandy for short. I am the Automation Panda. Be sure to read my blog and follow me on Twitter at Automation Panda. I also happen to be a freshly minted developer advocate at Applitools. If you don't know, Applitools provides visual testing tools to help make your apps look visually perfect. It's pretty cool stuff. In fact, Applitools today is leading a 2-day virtual conference called TAU The Homecoming. So if you want more testing content after this meetup, feel free to head over there. I'm speaking again in a couple hours. So in addition to all these wonderful things, I'm also the lead developer for Boa Constrictor, which is the .NET Screenplay Pattern. The Screenplay Pattern isn't exactly new. It's been around for a few years, but it is still new to a lot of folks in our industry. And I strongly believe that Screenplay is a much better way to interact with web pages than the traditional page object model. So today in this talk, my goal is to convince you of that claim in 3 parts. First, I'll cover problems with traditional ways of automating interactions. Second, I'll explain why the Screenplay pattern is a far superior way. And third, I'll show you how to use the Screenplay pattern with a C# library named Boa Constrictor. So to start, let's define that big I word that I keep tossing around. Interactions. Simply put, interactions are how users operate software. In this talk, I'll focus primarily on web UI interactions, like clicking buttons and scraping text. Interactions are indispensable to testing. The simplest way to define testing is interaction plus verification. That's it. You do something and you make sure it works. Think about any functional test case that you have ever written or executed. The test was really just a step-by-step procedure in which each step had interactions and verifications. Here's an example of a simple Duckduckgo search test. If you're not sure Duckduckgo, it's a search engine like Google or Yahoo or Bing. Steps here are pretty straightforward. Opening the search engine would require navigation. Searching for a phrase at Duckduckgo requires entering keystrokes and clicking the search button. And verifying results requires scraping the page title and the result links from the new page. As you can see, interactions are everywhere. They underpin our test steps. Unfortunately, though, our industry really struggles to handle automated web UI interactions decently. Even though a lot of teams use Selenium WebDriver in their test automation code, maybe some are now starting to use Puppeteer or even Playwright. Playwright's pretty baller. Every team seems to use it differently. There's lots of duplicate code and flakiness too. Let's look at the way many teams evolve their WebDriver-based interactions. I'm going to use C# for coding examples, and I'll continue to use Duckduckgo for testing. When a team first starts writing test automation code using Selenium WebDriver, they frequently write raw calls. So anyone familiar with the WebDriver API, regardless of language, should probably recognize the calls I'm going to show. The WebDriver object is initialized, say, using Chrome driver for the Chrome browser. The first step is to open the search engine. We'll call driver.navigate.goToURL with the Duckduckgo website address. Second step performs the search by fetching the web elements using driver.findElement, and then calling methods like sendKeys and click. Third step in our test uses assertions to verify the contents of the page title and the existence of those result links. Finally, hopefully, at the end of our test, the WebDriver quits the browser for cleanup. Like I said, these are all very common WebDriver calls. But if we look carefully, there are some big problems in this code. Can you see them? Race conditions. There are 3 race conditions in this code in which the automation does not wait for the page to be ready before making interactions. Ouch. WebDriver does not automatically wait for elements to load or for titles to appear. You got to do that yourself. Weighting is a huge challenge for web UI automation. And it's one of the reasons why we have flaky tests or intermittent failures. It's not necessarily a problem with the tool of Selenium WebDriver. It's how we use it and how we write our automation code. So there's a couple ways we could solve this. First, you could set an implicit wait that will make calls wait until target elements appear. But that's not universal because it won't work for, let's say, waiting for the title in race condition number 2. Explicit waits provide much more control over waiting and timeouts. In fact, it's usually recommended to use explicit waits instead of implicit waits. Explicit waits use a WebDriver wait object, shown at the top there, with a preset timeout value. And you got to make these WebDriver wait calls explicitly throughout your code. Here, I put them in the 3 spots where the race conditions were happening. Each wait.until call takes in a function that returns true once the condition is satisfied. These waits are necessary to avoid the race conditions, but they cause new problems. First, they cause duplicate code because those web element locators are used multiple times. Notice how search form input homepage, that ID, is called twice in these 2 lines. Second, raw calls with explicit waits make code less intuitive. If I remove the comment lines from each paragraph of code, what's left is a bit of a wall of text. It's difficult to understand what this code does at a glance. To remedy these problems, most teams use the page object pattern or the page object model. In the page object pattern, each page is modeled as a class with locator variables and interaction methods. So a search page could look like this. At the top, there could be a constant for the page URL and variables for the search input and the button locators. Notice how each has an intuitive name. Next, there could be a variable to hold the WebDriver reference. This reference would come via dependency injection through the constructor. The first method we want would be a load method that would navigate the browser to the page's URL. And the second method would be a search method that would wait for the element to appear, enter the phrase into the search input field, and click the search button. This page object class has a decent structure and a mild separation of concerns. Locators and interactions do have meaningful names. Page objects require a few more lines of code than those raw calls at first, but their parts can easily be reused. The original test steps can be rewritten using this new search page class. Notice how much cleaner this new code looks. The other steps can be rewritten using page objects as well. Unfortunately, page objects themselves suffer problems with duplication in their interaction methods. Suppose a page object needs a method to click an element. We already know the logic. Wait for the element to exist, and then click it. But what about clicking another element? This method is essentially hard-coded for one button. We would need a second click method to click another button. Ugh. The code for both of these methods is essentially the same. And the code would be the same for any other click methods too. This is copy pasta. This is bad. This happens all the time in page objects. I mean, I've seen page objects grow to be like thousands of lines long. Possibly, like, I can't remember exactly, but I'm pretty sure I've seen a page object that was over 10,000 lines long because people just copy and paste repeatedly. High scale, man, it happens. Large test projects, it's easier just to stick on new methods to a page object than to try to find one that fits your needs. And so these page objects can just grow and grow and grow due to duplicative methods like this. Now, at some point you might say, well, hold on, Mr. Panda. More duplicate code? I think we can solve that with some more object-oriented programming. And so the next step in the evolution of a page object implementation is usually to bring in inheritance. And folks will create this infamous base page parent class. You've probably seen it if you've worked in these things. It may not be called base page, for some reason it seems to be the most common name. I'll spare you my opinions. But anyway, they'll create the base page, and it's going to be the superclass for all other page classes. And the format's going to be pretty universal too. Base page will have variables for the WebDriver and the weight object, like we saw before. It'll also have common interaction methods rather than specific ones. So it'll have something, let's say, like this click method that can, pardon me, that can click on any element given an arbitrary locator. So abstraction for the win, right? We solved it. We solved page objects. So now when we look at how child pages would inherit this, the child page will inherit everything from the base page. Then child page interaction methods frequently will just call their base page methods. So you can see if we wanted to click one button, you called click. Click another button, click with the other locator. Done, right? That's when a lot of teams will say, we solved it. Page objects for the win. Good enough, right? 差不多可以. Timeout. Nope, not so fast. In my opinion, this really isn't very good at all. It's better than what we had before, but it's still categorically bad. Base page helps mitigate code duplication, but it does not solve the root cause. We still have the problem here. Page objects inherently combine two separate concerns: page structure and interactions. Interactions are often generic enough to be used on any web element, like we saw with the click. Coupling interaction code with specific locators or pages forces testers to add new page object methods for every type of interaction needed for an element. That's why we get so much duplication. Every element could potentially need to be clicked, to have its text scraped, to check if it's displayed or attached to the DOM, or any other type of WebDriver interaction. The API is huge. That's a lot of extra code that should not be necessary, right? Code duplication is code cancer. This base page then also becomes very top heavy as testers add more and more code to share, right? You can have, instead of having 1,000 lines long page objects, you're also going to have thousands of lines long base page, which becomes a single point of failure. If somebody goes in there and edits something and breaks it, it affects everything. This is no bueno. This is typohau. This is nicht gut. Very bad. So that's not even the end of it. Most frustratingly, at least to me, is that page object code I showed here is just one implementation. What do your page objects look like? Do they look like mine? Are they different? Are they special snowflakes? I would bet dollars to donuts that your page objects look different than mine. Page objects are completely freeform. There may be similarities, but they are freeform. Every team implements them differently. There is no official version of the page object pattern. There is zero conformity in design. Even worse, within the design, there is almost no way for the pattern to enforce its practices, which in my opinion is one of the cornerstones, the hallmarks of what we call design patterns in programming, is that it forces you into an opinion way of doing something. Page objects can't do that. There's no force on you to do anything. That's why you have people ending up arguing over things like, should locators be public or private? Wow, that's what we're spending our time arguing on? Okay, cool. So page objects would be better described as a convention rather than a true design pattern. Mic drop. Let that rest there for a moment. Page objects would be better described as a convention than a true design pattern. There's got to be a better way. Thankfully, I think there is. Let's take a closer look at how these interactions happen. When we're doing interactions, first of all, there's someone who initiates the interactions. Usually this would be like a user or a tester, or maybe some automated script. They're the ones who are making the clicks and taking the scrapes. Let's call them the actor. Second, there is the product under test. For our examples in this talk, that's going to be a web app, Duckduckgo. It has pages with elements. Web page structure is modeled using locators to access the page elements from the DOM. Keep in mind, though, the thing under test could be anything else, like a mobile app, microservice, even a command line. Doesn't matter. Third, there are the interactions themselves. For web apps, they could be simple clicks and keystrokes, or they could be more complicated interactions, like logging into the app or searching for a phrase. Each interaction will do the same type of operation on whatever target page or element it's given. Finally, there are objects that enable actors to perform certain types of interactions. For example, browser interactions need a tool like Selenium WebDriver or Playwright to make clicks and scrapes. Let's call these things abilities. Actors, abilities, and interactions are each different types of concerns. We could summarize their relationship in one line. Actors use abilities to perform interactions. Actors use abilities to perform interactions. This is the heart of the screenplay pattern. In the page object convention, page objects become messy because concerns are all combined. The screenplay pattern separates concerns for maximal reusability and scalability. So let's learn how to screenplay using Boa Constrictor. Boa Constrictor is an open source C# implementation of the screenplay pattern that my team and I developed while I worked at Precision Lender. It is, to this day, the cornerstone of Precision Lender's end-to-end test automation solution. With Boa Constrictor, Precision Lender runs up to 10,000 web UI REST API end-to-end tests on a daily basis from continuous integration at a scale of 50 to 100 times parallel, up to 100 tests concurrently. We blast through I think the rate is like about 1,000 tests in 10 minutes, like bringing up the browser, doing all the stuff, close it. It's pretty phenomenal. 99+% reliability. It's very, very reliable. Boa Constrictor can be used with any .NET test framework like SpecFlow or NUnit, Precision Lender Team, SpecFlow. Boa Constrictor also has a rich doc site hosted using GitHub pages. The repository, the doc site, and the NuGet package links are listed here. One other thing you might want to check out, during my time with the Precision Lender team, we actually wrote a case study in collaboration with SpecFlow at Tricentis on how Q2, the parent company, used BDD and SpecFlow together with Boa Constrictor to automate and run tests for the Precision Lender application. So if you want to get the full details on that massive solution, check it out. I'm sure you'll dig it. So let's rewrite that Duckduckgo search test from before using Boa Constrictor. As you watch this talk today, just follow along with the code. If you want to get hands-on with the code, which I strongly recommend afterwards, go to the Boa Constrictor doc site. There's a full hands-on tutorial in 3 parts with Web UI and REST API. That's the best way to learn Boa Constrictor. So to use Boa Constrictor, you need a couple packages. You'll need the Boa Constrictor package, which should automatically suck in REST Sharp and Selenium WebDriver from NuGet. And my example code is also going to use Fluent Assertions, which is a very nice C# library for making assertions. And I'm going to use Chrome and Chrome driver for my Selenium WebDriver. So let's get started, jumping into some Boa Constrictor calls. First thing is the actor. Everything starts with the actor. The actor is the entity that initiates interactions. All screenplay calls start with the actor. And most tests really only need one actor. Actor class optionally takes 2 arguments. First is a name, which helps describe who the actor is and will appear in the log messages. The second argument is a logger, which will actually send event messages to logs like a publish subscribe. Loggers must implement Boa Constrictor's iLogger interface, and console logger is one of the ones you get out of the box that just dumps it all to the command line or the console. You can also define your own custom loggers by implementing iLogger. Next, abilities enable actors to initiate interactions. For example, an actor needs a Selenium WebDriver instance to click elements on the web page. Let's read this line in plain English. The actor can browse the web with a new Chrome driver. Boa Constrictor's fluent-like syntax makes its call chains very readable. Actor.can adds an ability to the actor. Browse the web is an ability that enables actors to perform web UI interactions. Browse the web.with provides the WebDriver object that the actor will use, which in this case is a new Chrome driver object. Boa Constrictor supports all browser types, just like Selenium. All abilities must implement the iAbility interface. Actors can be given any number of abilities. Browse the web simply holds a reference to the WebDriver object. The web UI interactions we'll see soon will retrieve this WebDriver object from the actor. Now, before the actor can actually call any interactions, the web pages under test need models. Now, this is going to be a little different than a page object model, and you'll see why in a moment. The Screenplay models should be static classes that include locators for elements on the page and possibly other data like page URLs. But, big but here, page classes should only model structure. They should not include any interaction logic. Why? Separation of concerns. So, the Screenplay pattern separates the concerns of page structure from interactions so that interactions can target any element, maximizing code reusability. As we said before, interactions like clicks and text scrapes work the same, regardless of the target element. So here in our search page, we got two members. First is a URL. Second is a locator for the search input. In Boa Constrictor, we treat locators very seriously. Locator has two parts. First is a plain language description for that locator, for that element. We use that for logging. It also helps in debugging. One thing that really frustrates me is when people just drop in long selectors, especially in some of the newer frameworks like Playwright or Cypress or Puppeteer. They'll just drop in this lengthy CSS selector. They like hard-coded text. And it's like, that doesn't tell me anything about that element, right? It shows where to find it on the page, but it doesn't tell me what that element is supposed to represent. Is that supposed to be a search button, search input, something else? Because as soon as that DOM changes, because some developer is working on it, and your CSS selector or your XPath no longer lines up, you've lost all context for what that element was supposed to be. Boa Constrictor, you give it a name so that you know, this is the Duckduckgo search input. So if Duckduckgo decides to change wherever that thing is on the DOM, at least when I go back to update my automation code, I know what the thing is supposed to be. So we give a description, and we also give the selector query. For Selenium WebDriver, we just use the by queries, right? Drop in objects, no different, right? Fully compatible. One design principle I've had with Boa Constrictor is to try to keep the object for the interaction methods, not methods classes, for the interactions that Boa Constrictor has, WebDriver and REST API, to keep the same kinds of objects that those libraries use, right? So it's seamless. We don't need to put an adapter or anything on top. So this is the structure of a Screenplay page class. Structure only. Very declarative. Also, you may notice in that search input, it's using an L method to construct. The L method is simply a static method, static builder method that will basically say return new web locator with the stuff. It's just a convenience thing, so you don't have to type that out every time. So we got the actor can browse the web, and we have the search page modeled. Now we can do some interactions. Screenplay pattern has two types of interactions. The first type of interaction is called a task. A task performs actions without returning a value. Examples of tasks include clicking an element, refreshing a browser, and loading a page. These interactions all do something rather than get something. Boa Constrictor provides a task named navigate for loading a web page using a target URL. So let's read this line in plain English. The actor attempts to navigate to the URL for the search page. Again, Boa Constrictor's fluent-like syntax is very readable. Clearly, this line going to load the Duckduckgo search page. Actor.attempts2 calls the task. All tasks must implement the iTask interface. When the actor calls attempts2 on a task, it's effectively calling the task's perform as method. Navigate is the name of the task, and .toURL provides the target URL. The navigate task's perform as method fetches the WebDriver object from the actor's ability and then uses it to load the given URL. That's that backdoor dependency injection at work. Beautiful. Searchpage.url comes from the search page we previously wrote. I put the URL in here just to make it universally available. Typically in a real world test automation project, don't do that. Don't hard code your base URLs because you might be targeting multiple environments. You should read that in as an input, but toy project, toy example, more for learning, just go with it. And disclaimer. So that's a task. Second type of interaction is called a question. A question returns an answer after performing actions. Examples of questions include things like getting an element's text, location, appearance, basically querying any kind of state. Each of these interactions returns some sort of value, right? Ask a question, get an answer. Boa Constrictor provides a question named value attribute that gets the value of the text currently inside an input field. So read this line in plain English. The actor asking for the value attribute of the search page's input should be empty. Actor.AskingFor calls a question. All questions must implement the iQuestion interface. When the actor calls asking for, or the equivalent asks for method, it is calling the question's request as method. Value attribute is the name of the question, and .of provides the target web element's locator. The value attribute's request as method fetches the WebDriver object again from the actor's ability, waits for the target element to exist on the page, avoiding that race condition, scrapes the value, and then returns it as the answer. Search page.search input is the locator from that search page that we created to get the input element. Boom. Finally, once the value is obtained, the test must make an assertion on it. Should be empty is a fluent assertion that verifies that the search input field is empty when the page is first loaded. Cool beans. Test case's next step is to enter a search phrase. Doing this requires two interactions: typing the phrase into the search input and clicking the search button. However, since searching is such a common operation, we can create a custom interaction for search by composing those two lower level interactions. The search Duckduckgo task takes in a search phrase, and in its perform as method, it calls two other interactions: send keys and click. We've seen these before. Using one task to combine these lower level interactions makes the test code more readable and understandable. It also improves automation reusability. Read this line in plain English now. The actor attempts to search DuckDuckGo for panda. What y'all think? That's concise and intuitive. It's very nice. The last test case step should verify that the result links appear after entering a search phrase. Unfortunately, this step has a race condition. The result page takes a few seconds to display result links. Automation must wait for those links to appear. Checking too early will make the test case fail. Boa Constrictor makes waiting easy. Read this line in plain English. The actor waits until the appearance of result page result links is equal to true. A little bit simpler terms, wait until the result links appear. Boom. Waits until is a special method. It will repeatedly call a question until the answer meets a given condition. For this step, the question is the appearance of result links on the result page. Before the links are loaded, the question will return false. Once the links appear, it'll return true. The condition for waiting is for the answer value to become true. Boa Constrictor provides several conditions out of the box, such as equality, mathematical comparisons, and string matching. You can also implement custom conditions by implementing the iCondition interface. Waiting is smart. It will repeatedly ask the question until the answer is met, and then it will move on. This makes waiting much more efficient than hard sleeps. If the answer does not meet the condition within the timeout, then the wait will raise an exception. The timeout defaults to 30 seconds, but it can be overridden. Many of Boa Constrictor's WebDriver-based interactions already handle waiting. Anything that uses a target element, such as click, send keys, or text, will wait for the element to exist before attempting the operation. We saw this in some of the previous example code. However, there are times where explicit weights are needed. Interactions that query things like appearance or existence, check if it's there or not, do not automatically wait because they can't, right? You need to, if you're checking the state of something in the system, it's instantaneous, true or false there or not. The final step is to quit the browser. Boa Constrictor's quit WebDriver task does this for you. If you don't quit your browser, it could remain open, turn into a zombie process. So always, always, always quit your browser. Furthermore, in whatever test framework you use, make sure to put this in the cleanup routine or the teardown. That way it'll get called even when the test fails. And voila, there we have it. Our completed test for Duckduckgo searching using Boa Constrictor Screenplay Pattern. All the separated concerns come together beautifully to handle interactions in a much better way. Screenplay Pattern can be used for more than Web UI. Boa Constrictor has interactions for REST APIs as well using REST Sharp. So real quick, let's step through a REST API test as well. Actor will be the same as before, no change there. But to call REST APIs, the actor needs an ability named call REST API. It uses REST Sharp's REST client with a base URL. For this test, we'll use a public API called dog API, which returns random pictures of dogs. Side note, one actor can have multiple abilities, as long as each ability has a different type. Boa Constrictor uses REST Sharp's REST request objects directly, which specify resource path and HTTP method. To call the REST API, Boa Constrictor uses this. The actor calls the REST request, and you pass in the REST request object. Once you get to the response, you can check it for things like response code and other data. This test is pretty basic, but Boa Constrictor can do some advanced tricks as well, like downloading files, dumping responses, and deserializing bodies. REST API interactions may also be composed with Web UI interactions. You get some joint synergies there. It's beautiful. So, as we said before, the screenplay pattern can be summed up in one line. Actors use abilities to perform interactions. It's that simple. Actors use abilities to perform interactions. For those who like object-oriented programming, Screenplay Pattern is, in a sense, a solid refactoring of the page object convention. Solid refers to 5 design principles for maintainability and extensibility. I won't go into detail about each principle here because the information is a bit dense, but if you're interested, snap a quick screenshot and check out each of these principles later. Wikipedia is a great source. They've got some good articles on each. You'll find that the screenplay pattern follows each principle very nicely. So, why should you use the screenplay pattern over page object convention or raw WebDriver calls? A few key reasons. First, the screenplay pattern, and specifically Boa Constrictor, provide rich, reusable, and reliable interactions out of the box. Boa Constrictor already has tasks and questions for every type of WebDriver-based interaction. And like I said before, each one is battle hardened and safe to the tune of 10,000 tests on a daily basis. It's solid. It scales. Trust me. We have a case study to prove it. Second, screenplay interactions are composable. Like we saw with searching for a phrase, you can easily combine interactions. This makes code easier to use and reuse, and it avoids lots of duplication. Third, the screenplay pattern makes weighting easy using existing questions and conditions. Weighting is one of the toughest parts of black box automation. Fourth, screenplay calls are readable and understandable. They use a fluent-like syntax that reads more like prose than code. And finally, screenplay pattern at its core is a design pattern for any type of interaction. In this talk, I showed how to use it for web UI and a little bit of how to use it for REST API. But you can also do screenplay for mobile, for other platforms, for, I don't know, SSH commands, command line, whatever. Interactions are interactions. It's all black box testing. You can also make your own interactions too. Overall, screenplay pattern provides better interactions for better automation. That's the point. This is not just another Selenium WebDriver wrapper. It's not a new spin on page objects. Screenplay is a great way to exercise any feature behaviors under test. And as we saw before, it's not that complicated. Actors use abilities to perform interactions. That's it. The programming behind it just has some nifty dependency injection. So if you would like to start using Screenplay Pattern for your test automation, there's a few ways to get started. If you're programming in .NET, good news, you can use Boa Constrictor. Woo! If you're programming in Java or JavaScript, you can use Serenity BDD, which is a mature, complete test automation framework that includes the Screenplay Pattern. In fact, Serenity BDD was like the first major implementation of Screenplay. Serenity BDD greatly influenced Boa Constrictor, but I want to point out these are two entirely separate projects. And they also have different goals. Boa Constrictor is not Serenity BDD for .NET. Distinctly, it is separate. Boa Constrictor aims to be a simpler, standalone implementation of Screenplay that can be used by any .NET framework, whereas Serenity BDD is a comprehensive all-in-one. If you want to use part of it, you got to use all of it. If you're programming in Python, I'm going to ask you, please have some patience. In my spare time, I've been trying to implement a Screenplay pattern in Python, very similar to Boa Constrictor, just haven't gotten there yet. So hopefully, now that I'm a developer advocate, I might have some more time to work on it. But it's coming, I promise. Don't know when, but it's coming. And if none of these options suit you, you could always create your own. Screenplay Pattern does require a bit of boilerplate code, but it is worth it in the end. You can always reference code from Boa Constrictor because it is open source to kind of see how to make it happen. If you want to learn more about Boa Constrictor, please visit our doc site. It provides thorough information about the project and the Screenplay Pattern. I recommend taking our hands-on tutorial so you can develop a test automation project yourself with Boa Constrictor and NUnit. It covers both the web UI and REST API interactions. Also, since Boa Constrictor is an open source project, I would love for you to contribute. In fact, we participated in Hacktoberfest 2021 back in October, and we had a lot of folks from the community come in, close out some issues, give us some pull requests. It's a really, really awesome time. If you look at our contribution chart, it was bing, way up for October. So thank you so much for taking time to learn about the Screenplay Pattern with me today and about Boa Constrictor. I want to thank everyone at PL and Q2 who helped make Boa Constrictor's open source release happen over a year ago. And again, my name is Andy Knight. I'm the Automation Panda. I'm a developer advocate at Applitools. So please be sure to read my blog, follow me on Twitter, hit me up on LinkedIn, and reach out to me if you'd like to join the Boa Constrictor project. Thank you very much, and I'll open the floor for questions.
Oh, thank you very much, Andy. I just want to let everyone know you can now unmute yourself if you want. And if you have a question, just ask away. If you don't have a microphone, you can ask the question in the chat and I will read it out so the other people can also hear it and Andy can reply.
I have a question, Andy. Thank you for the presentation. I was yesterday in your playwright presentation also.
Oh, nice.
Yes, and I wanted to ask you if it is possible to use both actually, screenplay and playwright together.
Ah, that's a fantastic question. So I have plans to add playwright support to Boa Constrictor. I am going to be meeting with the other Boa Constrictor maintainers sometime this month to discuss what our roadmap looks like. And I'm hoping a Boa Constrictor 3.0 can have, or maybe a 3.1 can have playwright support. So stay tuned for that. Hopefully Q1 of 2022, that can happen.
Thank you.
Okay. Like I said, if you have any questions, just ask away. Until then, I have a question. In the beginning, you mentioned that a good design pattern is kind of self-enforcing, and the page object model doesn't really provide that. In what way does the screenplay model basically self-govern itself?
Yes, great question. So when you use the screenplay pattern, basically everything is tied to the actor, right? You add abilities to the actor, then with those abilities, you can have the actor perform any interactions. Any of the more granular stuff, like direct calls to Selenium WebDriver, are hidden from you by design, right? You only want to make WebDriver calls or REST sharp calls from within the interaction code. You don't want to be doing that at the top level of your test. So what you can do with a test framework, for example, let's say like SpecFlow or NUnit, you can inject the actor into the test with the ability it needs for browsing the web or calling REST APIs. So that way your test case in the test case scope or the test step scope, it won't have direct access to the WebDriver or the REST client, but it will have the actor preloaded with abilities, and then it can just call the interactions. And that way, the test itself will only ever have just the pieces it needs to do the interactions. So that is the big way that Screenplay will enforce you to use the pattern, right? Because you can limit that that's all you get, and that's what you're going to have to use. And so it encourages people to think in terms of interactions. And if they need to do something, either to use an interaction that already exists or perhaps to make a new interaction for it.
Thank you very much. Great answer. So basically, you take the ability of the page away to do something. Only the actor can do stuff. Awesome. Thanks. Great answer. Serene, you want to ask again?
Yeah, sorry, but I'm a bit curious because I am familiar actually with the Screenplay. We have Serenity framework inside our company, and it's done by Daniel actually, who is raising his hand. The one fact that I don't like about Screenplay is using the actor names. It's not only this actor name who is able to do those stuff, so that's why I don't like it. Could we use other stuff rather than using the name of the actors? Like as Daniel, I can book a trip or something like that. As a user, I can do that, not as Daniel or as, I don't know, Andy or...
Sure. So I don't have as much hands-on experience with Serenity BDD because I haven't worked in a big project with it. I know that in Serenity BDD, they focus a little bit more on the name of the actor, right? Within Boa Constrictor, actor is literally just an object. It's not meant to represent a persona necessarily. In Boa Constrictor, the actor is literally just the initiator of interaction. It's the starting point. So the class name is called actor, but I mean, you could name the instance variable to be whatever you want. There's not necessarily like a role or a permission aspect to an actor. It's literally just the thing that calls interactions. So I would say if you wanted to give the actor a different name the variable something different. That's about all I can say.
Okay, thank you.
Tillman has a question. Oh yes, sorry, go ahead if it's a follow-up.
Andy, I have a question. My main question is just, as you said, this screenplay pattern is implemented by your framework and also by Serenity BDD. There is also another implementation with JavaScript by Jan Molak, Serenity JS.
Yes.
And my main question is, I really see the advantages of this pattern, and I really don't understand why you think, on your opinion, why there aren't more frameworks out there existing, and why this isn't more embraced by the testing community in general, as I expected it should be.
Yes. Yeah, I totally get it. I have some very hot, spicy takes on this. So here goes. I'm not going to hold back. Page objects have been around for over a decade, right? When they hit the scene shortly after WebDriver hit the scene, right? We're talking like 2008, 2009, 2010. At that time, the whole world was still enthralled with object-oriented programming. And the thought was, let's take any type of concept and shoehorn it into the structure of a class. Ta-da! Oop! It happened. And now we're better for it, right? And so it was that idea that's where page objects came from. They were meant to be a simple way to be better than just making raw calls, as we saw in the evolution that I gave in my talk. And so because page objects were so simple and it fit the mode of thinking that the least common denominator who understood object-oriented programming could understand, that's how page object structure happened. Let's just shove everything into the structure of a class. Same thing happened with unit testing with X unit stuff. I have opinions about that too. We're not going to go into it, but it was like, okay, we can put it all in this one thing, and that's a class represents a page, and it became very popular because it was categorically better than raw calls. It was something easy enough for the average person to understand, even if they didn't have very much programming experience. And it was easy to set up. You could just do it yourself. You didn't need a dependency package or anything. It was just get up and go. So then a couple years later, when Screenplay first hits the scene, people like John Ferguson Smart, John Molak, I forget the other guy's name. I can see his face. There was like a group of people, mostly in the Serenity world, that were like, hey, page objects aren't that great. Let's do something better. And so they came up with the Screenplay pattern and they pushed it out big, and they made a big effort. Like you can look back 2013 to 2015, they did a bunch of articles, a bunch of talks. Serenity started becoming big and they started putting it out there. I found two problems with that. Now, I'm going to say I very, very, very much respect that entire crew. I look up to them. I admire them. They do excellent work. They're very smart. They're very bright. They're on point with a lot of things they're saying. I'm friends with some of these people too. And I make no bones about it. Serenity BDD inspired Boa Constrictor, right? I read their articles like 3 or 4 years ago, and that's what jump-started me to start the Boa Constrictor project. But two issues I had with when all that went down. First of all the material they pushed out seemed kind of complicated. It seemed complex. It seemed a little confusing. And I think the way they pitched it and the materials that they put out and the articles they put out made it seem a little more complicated than it had to be. And so the average person kind of looked at that and was like, I don't understand this. This doesn't make sense. Huh? I'm confused. I'm going back to page objects. So there was a steep learning curve to Screenplay. Problem number one. Problem number two was that everything in Screenplay that was available was in Serenity. That was like the framework that had it. There weren't other major implementations. It did not exist outside of the Serenity world, because all these guys who were pushing Screenplay happened to be in Serenity world. And they're we'll just add this to our amazing framework, which it is pretty sweet. But it's like, okay, now, so if you want to do Screenplay, you got to get the whole Serenity bathtub. And it's like, but I'm already using JUnit, or I'm working in C#, right? I'm not going to completely change over my project to use this kind of all-in-one solution just because of a better design pattern that they have. And because, like I said, Screenplay requires like this much boilerplate code, the average layman is not going to rip open Serenity BDD code, look at it, and copy it on their own in their own project. So I think those were the two big barriers to entry for the vast majority of the testing community. And I think that's why Screenplay never really caught on, even though objectively in terms of software design, it is by far the superior pattern over page objects. So one of my big reasons for one of my driving forces behind the Boa Constrictor project is not to get people using Boa Constrictor. So that would be awesome. My big mission with this is to reawaken the talk around Screenplay Pattern, and specifically around better automation practices and patterns, because I think page objects are terrible. They're better than raw calls, but for projects at scale, oh gosh, it's night and day. Page objects, like I said, they just blow up like balloons and then explode, and they're unmaintainable. Screenplay is way better. I've worked on similarly sized projects at my previous company and my previous company, both SpecFlow, both web UI testing, both C#.NET. 2 companies ago was page objects. 1 company ago was Boa Constrictor Screenplay. And in fact, I developed Boa Constrictor as a reaction to 2 companies ago of the mess that the page objects caused at scale. And it was night and day better. Like the success rate of tests because of reliability, the lines of code in the entire repo, lines of code per test, way shorter. Like it's night and day better. So what I'm hoping to do with the Boa Constrictor project, as well as repeatedly giving this talk about the Screenplay pattern everywhere I can, is to get people to realize this is better, to get people to realize Screenplay is not that complicated, right? It doesn't have to be super complicated and weird. Actors use abilities to perform interactions. Boom. That's it. There's just some dependency injection behind it. It's easy. Here, I've implemented it for you. Go. Like you can make it yourself too. You want to get playwright interactions? Come help me. You want another library? Let's put it in. It's open source, right? And the fact that it's standalone within the .NET community. So you use SpecFlow, great, all yours, right? I'm part of SpecFlow's inner community. I love SpecFlow. They love me. Sabotage Andy, who's the community manager, who's been a longtime developer of SpecFlow. I introduced Boa Constrictor to him. He lost his mind. He's like, this is the greatest thing ever. I love this. I am never using page objects again. I'm never using driver pattern. I'm only using, he's like, he drank the Kool-Aid, man. I was like, if one of SpecFlow's lead guys is loving Boa Constrictor, I did something right, right? Or let's say you're not in SpecFlow. You want NUnit, you want XUnit.net, you just want to stick to Microsoft MS Test. It's compatible with all of them. You don't have to change your framework to use a better pattern.
Oh, great.
That's what I have to say about that.
Drop the mic, yes.
Boom. I told you it was spicy.
Yes. Serene, I want to, before I let you ask again, I wanted to repeat a question from Tillman. They are not convinced that the actor abstraction layer is worth it, since there's usually just one actor, and want to ask you, Andy, if you have a real life example with multiple actors, for example, or a single actor doing multiple things.
Yes, that one. Like I said, abilities basically provide tools to the actor. So abilities can do things like provide the Selenium WebDriver instance or a REST sharp client, or they can be a way to hold data and share data between interactions. So at my previous company, Precision Lender, our actor, every test would have one actor, freshly created, and that actor would have multiple abilities. They would have the ability to browse the web with a Chrome driver. They would have the ability to call REST APIs for both the Precision Lender public API and private API. 2 different abilities there, different types. It would have the ability to access inputs that we would pass into the automation project when we would launch it. It would have the access to store different pieces of information about things going on in the application. So that actor, I think, had total about 10 different abilities it was given. And the nice thing about abilities is, it's a separation of concerns, right? WebDriver is a perfect example. You have all the different WebDriver things like click and scrape and text and whatnot, right? But you could have it done with different kinds of drivers, right? So you could, in one case have the ability, have a Chrome driver. In another case, let's say you want to run Firefox instead. Well, boom, put that in there, that kind of thing. And the separation of concerns is that way you can dynamically add new kinds of interactions without having to change the actor itself or having to change the abilities themselves, right? I mean, in theory, you could write one giant base page class that has all the different kinds of interaction methods, right? You could write a click method and a text method that does the safe wait for the element and then get it and then return it stuff. But then what you've done is you created a single point of failure. You have one file that's like 10,000 lines long with all of your stuff in it. And, oh, you want to go add a new interaction, go add it to that class, boom, 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 right? That becomes fragile. The whole point is to avoid that, right? It's much safer to, in the idea of these solid principles and being safely extensible, don't edit an existing class, add a new class. Every interaction is a class, right? And so if you add a new interaction as a new class, it doesn't affect any of the other interactions. That's the point of this whole abstraction.
Thank you very much. Serene, go ahead. And you got a thumbs up from Tillman, so I assume happy with the answer, huh?
Yeah, I just want a question regarding Boa framework. Will you have it for other languages like Java and everything? Because I am not going to .NET or C# or any other thing.
I feel you. Great question. So I'm actually going to back up and explain why .NET first. The reason why Boa Constrictor is in .NET might be kind of weird. Like, why would you? It's because at my previous company, Precision Lender, I joined there April 2018, and I was brought in as their first software engineering test. I was given keys to the kingdom, told Andy, make the test thing happen for us because we need it. I'm like, okay, cool, right? Precision Lender was a Microsoft .NET shop. Everything was Microsoft. All the cloud infrastructure was Azure. Their back end was C#. Their front end was JavaScript, TypeScript. And so I chose to implement our test automation solution in .NET as well to match what the rest of the company was doing. It was either going to be .NET or Python. And I realized very quickly, ain't nobody knew Python except the data scientist way in the corner. So I'm like, I have to fold here, which is okay because the previous companies that I worked in, I worked on a C# .NET SpecFlow WebDriver solution. So I was like, okay, I can repeat the same play, but make it better. Yeah, let's do that. So that's why Boa Constrictor is in .NET. The Boa Constrictor project started as an in-house thing. It didn't start as a public open source thing. It started as me reading articles from the Serenity crew and being like, wow, sounds like Screenplay is a lot better than that page object trash I dealt with at the previous company. Maybe I should try to use that for the solution I'm building. Oh, wait, there aren't any good implementations that I can find in .NET for Screenplay. Oh, and I'm not going to go to Java or JavaScript because we're a Microsoft.NET shop. Maybe I should make my own. Well, reading these articles, this is really complicated. I want to make it easier for people to understand this. And you know what? I don't like how it's tied to Serenity. I want to make it standalone. So even though we're going to use SpecFlow, I want to make sure we can use it with anything, right? It's just going to be drop-in. And so I developed it as part of the whole test automation solution, in-house, all that. But I tried to make it as good as possible because I wanted it to be nice. And then it wasn't until October of 2020 that I finally got approval and the support to separate Boa Constrictor, or to separate the Screenplay implementation from the main project, come up with the name, Boa Constrictor, and then release it open source to the community. So, and that was, just a little more than a year ago that it's been open source. And the maintainers have been me and that team of software engineers and test, the PL, with a few other randos who pop in and say, hey, one of whom is Sabotage Andy from SpecFlow. So we're a very small project, very small crew. That's why it's in C# right now. Now, are we planning to port that to other languages? No. I mentioned that I'm working on a Python implementation in my spare time. That will probably not be part of the Boa Constrictor project. That will probably be a separate project that I make. I might join it. I don't know. We'll see. The other thing is, like, would I bring it to Java? Would I bring it to JavaScript? There's far less impetus for me to do that because Serenity already plays in those spaces. You know, there's already a Screenplay implementation in Java as part of Serenity BDD. Is there an industry need to bring Boa Constrictor to those? Much, much less so. Yeah, it's, you know, it would be nice to have standalone drop-ins, but plus,
yes, we need it because it's a standalone. It's not like you have to adapt everything from scratch, from like Serenity. So yes, we need it. There is a need.
So the other thing I would say to that is also, Boa Constrictor is a very small project, right? We don't have unlimited resources and all these things. So right now, my goal with Boa Constrictor is make it as excellent as possible in .NET. What I would say is if folks really want other language implementations of this, go to the Boa Constrictor project, open up issues for it. There's like a forum, is like ask a question or recommend a new feature. Open up an issue in our project to start a conversation around this. Because we can get enough support and people are willing to step up and do it, I won't say no to people. I won't do a Java one myself, most likely. But if someone else is like, I want to take this, I want to port this entire API into Java, I'll be like, I'll review your code. If you want to do that, hopefully we won't step on any toes within the community, because I don't want the Serenity guys to be angry at me. You know, I like them, I like their work, but yeah, you know, another thing, maybe one could investigate, could you try to kind of tease out just the Screenplay implementation from Serenity instead of using the whole thing? Maybe that's another alternate route, and we could go talk to those projects and see if it's possible, see if they can make it easier to do that. I don't know. The trick with Screenplay is that even though it's like we try to focus narrowly on the interactions, there are some entangling things, like when it comes to logging or event publishing, right? That's where it kind of crosses a little bit. Reporting as well. It's like, well, if you want to get some more nifty little hooks in there. So it's a challenge to make Screenplay standalone because of the nature of the things it touches. It's not impossible. We did it with Boa Constrictor, but it's something that needs to be carefully thought out. So sorry that I can't just boom, clap my hands and give you a Java Boa Constrictor. Sorry. If only.
What's about Android and speed of Boa Constrictor?
What about the speed of Boa Constrictor? I mean, I don't think it's any slower than like PageJava. I mean, I haven't done any benchmarking or anything. Like there is going to be like a nanosecond hit because it's got more object-oriented stuff in the way. It's got to jump through the object references and stuff. But honestly, when we're talking about end-to-end test automation, like black box test automation, the compiled speed of a binary pales in comparison to the slowness of a website or a REST API. We're talking
just opening the browser.
It doesn't matter, right? So even if there's like a little bit of inefficiency within the way Boa Constrictor does some of its object-oriented stuff, who cares, right? It doesn't matter. I guarantee your website is going to be much worse of a bottleneck, much worse of a performance crapper than the .NET runtime itself.
And does it support Android also, or?
So we do not have any interactions for anything mobile yet. If somebody wants to contribute that, I am all open. So just kind of like I said, we don't have Playwright yet, but we're going to add those bindings. If people want other kinds of products to support, we can add it. We can bring it into the Boa Constrictor project, or you can just make it on your own. Like, I don't feel like contributing back. I'm just going to milk it for all it's worth. Cool, whatever you use in Screenplay, I'm cool with that. You want to make some Android bindings or some Android interactions? Go for it. Ain't nothing to stop you.
Awesome. Thank you very much. Very in-depth question and answers. Very happy. Unless there are any more questions,
I see one in the chat. Why did you choose the name Boa Constrictor?
Oh yeah, Aurelian's question. Yes, I saw this as well. Yeah.
Most important question.
Yeah, I'm scrolling up. I see a lot of questions here. If we got time, I can just try to crank through some of these. So the name Boa Constrictor actually stems from the in-house name of Precision Lender project. When I started at PL 3.5 years ago, that org didn't really know anything about large-scale test automation development. Was not a thing that they were aware of. That's why they brought me in, right? And so trying to explain how I was going to develop a solution for end-to-end web UI, REST API, black box, automated tests, that's a mouthful, right? I was like, I need a catchy name, something short and sweet as like a brand for this type of testing that we're doing. Nice. So I thought long and hard, and I came up with the name Boa. Why? Because it was short, it was unique, it could be seen as an acronym, behavior-oriented automation. It could be seen as a tongue-in-cheek for one of our customers, one of our big customers. I'm not going to name it, but you could probably figure it out based on the acronym. It's tongue-in-cheek to that. And because originally I was debating between doing it in Python or C#, and if you know me, you know Python's my favorite language. So you're like, Andy, why are you doing .NET? Well, if I can't do it in Python, give me another snake name, Boa. So internally in PL, they became known as Boa tests, right? And that was the full, the spec flow with the screenplay and right. So we call them Boa tests. To this day, people call them Boa tests. They have about 2,000 unique Boa tests. They run them on different configurations. They run up to 10,000 Boa tests a day. So when it came time in about a year ago to release Boa Constrictor as an open source project, we're like, okay, well, we got to go through this whole name thing again because we're separating out part of the implementation. I didn't want to call that Boa because that would be confusing internally. It's like, what about Boa Constrictor? And we okay, put that on the list. And we came around a couple names like, that's the best we can come up with. So the screenplay implementation that we have is Boa Constrictor. And we have this really badass logo.
Yes, great.
Thank you.
Choke out those bugs, yeah, pure force. Yes, if you still have the time, Daniel, I think also had a question about reporting. If Boa has any built-in reporting.
No, but yes. So, like I said before, as a standalone implementation of Screenplay, I wanted to be narrow in the concerns that Boa Constrictor handled. I wanted it to focus primarily on interaction. There's a lot of things going on within a test automation solution that could be handled. I did not want to handle extra things. I did not want to have an assertion library, right? That's why we import fluent assertions. Reporting was one thing I did not want to do because Boa Constrictor is not necessarily a test library. It's an automation interaction library, right? You could use Boa Constrictor for straight up like web scraping. Doesn't have to even be paired with a test framework, right? Of course, the vast majority of people I know using it use it for test automation, but that's also a very small community. Anyway, so no, there aren't like full test reports that Boa Constrictor gives, but we did smash in one kind of test report like thing to trace messages and captured artifacts like screenshots and request dumps. Why? Because it was easier just to shove it in there. I haven't publicly talked about it. I haven't written a user guide on it. It's kind of ick, but it works. It's mostly a precision lender thing. I still have it in the back of my mind that I haven't fully decided if I want to keep it in the Boa Constrictor project or to kind of push it back to them and be like, you own this. I don't want this in the project. But it is in there. You can go in the GitHub repository, dig around in the source. You'll find it. I won't tell you where it is, but you'll find it. Good luck. If you really want to learn more about it, message me afterwards and we can chat.
Awesome. Thank you, Andy. Any more questions?
I have a question.
Sure, go ahead.
Yeah. Just recently, I heard a presentation about what is life after Selenium, and there was Puppeteer and something similar introduced, and that's new to me just as well as a screenplay pattern. But I do agree with all these problems which have been now talked about with the page object pattern and also with a not event-driven behavior of WebDriver. Now I'm wondering, for what should I go? I mean, which should I learn next? It seems like this, what you are showing here, Andy, it's like not as cool as something which is actually really event-driven. Do you understand what I mean?
I feel you. I feel you. I mean, when it comes to the next steps in web UI testing for automation, honestly, I think personally, the next big thing is going to be Playwright. I wouldn't go to Puppeteer because all the people who worked on Puppeteer went to Microsoft and started Playwright. Like, hot take, I don't think Playwright is, or I don't think Puppeteer is dead, but when all the great minds went to go work on a new project under a much more, what's the word I'm looking for? Generous benefactor. And Playwright, yep. And Playwright supports multiple language bindings versus Puppeteer is only JavaScript. Playwright is JavaScript, Java, .NET, and Python. Surprisingly, Ruby is not on that list. I don't know what's up with that. Another hot take question, WTF. Anyway, I'm not a Ruby guy. I'm a Python guy, so I'm happy Playwright's in Python. My gut tells me that in the next 5 years, Playwright is going to be the major contender against Selenium WebDriver. I think there's some things that Playwright still needs to work out, like massive scale out, because Playwright doesn't have something like Selenium Grid yet. And a lot of the vendors like Sauce Labs, and I don't think they yet have support for Playwright, though I hear it's coming, or it's like very, very new. Again, I'm not from Sauce Labs. I'm from Apple Tools. I don't have dog in that horse. But I truly believe, as long as Microsoft doesn't screw it up, again, more hot takes, I'm letting it fly today. As long as Microsoft does not screw Playwright up, it could very well be the replacement for WebDriver. And I'm new to Playwright, and I'm making bold claims like that. So I think that is where that's going. Honestly, when I look at Playwright and I look at Boa Constrictor side by side, let's just stay in the .NET realm. Playwright, or one of the big reasons that we developed Boa Constrictor at Precision Lender and used the Screenplay pattern was that the Screenplay pattern made it easy to make web calls safe, specifically things like automatically waiting for elements to be ready. Because that's something, if you just make raw WebDriver calls, it doesn't wait and you hit the race conditions, right? That's a big pain point. And so one of the things we did with Boa Constrictor is, if you look in all the WebDriver code for all those WebDriver interactions like click and text and all, you'll see before every single one of them, actor waits until this thing appears and then try to click it and then try to get the text. Playwright already does a lot of that. So that's one thing where it's like, oh, you don't need Boa Constrictor's implementation of the Screenplay pattern for that need that Playwright does. So it's like, ooh, so do you need Boa Constrictor, or do you need Screenplay pattern at all if you have something like Playwright? The answer is still yes, because Playwright is purely focused on the concern of browser automation. Playwright is not focused on the concern of interaction, right? Browser automation is something like click button at this selector. Interaction is log into your application, which could be made up of multiple small interactions like send this username to this input, this password to this input, click the button and wait, right? So there's still a place for something like Screenplay pattern, right? Where you would still be writing interactions that would model things, that would model behaviors of your application under test, of your features that you're developing. And inside at the lower level, use a tool like Playwright or even still Selenium WebDriver to automate the browser pieces of it. So these things still come together. I'm hoping that 5 years from now, when we're having these talks again, it's not going to be, page objects. The MO isn't going to be page object with Selenium. I'm hoping the MO is going to be Screenplay with Playwright. That's my dream for 5 years from now, or that's going to be the standard, the bleeding edge, the recommended practice, the one that is actually what people are not just talking about, but people are doing and have done.
Thank you, Andy.
Okay, thanks.
I recently saw at the Test.js Summit, I saw Andriy Lushnikov's pitch for Playwright, and damn, it was really impressive. I haven't used it yet. I'm currently on Cypress. I'm really happy with it. But Playwright is growing a lot, and it has a lot of potential. I was looking up the video. I can link it here. Sadly, it will only go public in 17 days, so I'm not sure if it makes sense. I will just link it here, and you can check it out once it's available. It was a really good pitch. Has me convinced to try it on a personal project at least.
Definitely.
I think you can play around with it for a couple of days and you already get a feeling of if this is something you want to work on for longer or convince other people at your company to check it out.
Yep. I mean, yesterday I just gave a whole workshop on Playwright in Python, and oh my gosh, like, oh man, I'm not going back to Selenium WebDriver in Python. Hell no. Also, it's interesting you mentioned Cypress. I'll drop some more hot takes here. I think Playwright is superior to Cypress. First of all,
they just lost Gleb, which is like half of Cypress to me.
Yeah. I mean, it's like with Cypress is so like the community and the tool are so JavaScript centric. It's almost to a point where like the community looks down on non-JavaScript things. It's like they live in a bubble. And I'm like, you do know that there's a lot of people in the test community that not only don't use JavaScript, but actually despise it. Whereas Playwright's like, oh, well, we'll do all the things just like Selenium did all the things. And so I predict that, Cypress, and I don't think about Cypress. If you, again, I haven't used it hands-on much, but I've read a lot of articles and seen like speed-wise, Playwright beats the pants off of both Selenium and Cypress. Like great. Like, oh my gosh, I have one of those new M1 Max. Just yesterday, I was running in Python, which is slower, right? Some Playwright tests, and it's like I was able to blaze through 30 tests in like 10 seconds. Like what? Like web UI
full
tests.
UI with browser and everything.
Like bring up the browser, shut it down. Like 10.
Damn.
Like I did one round where it was 10 tests in parallel. All the tests completed in 1.2 seconds. It was nuts. I was like, and that's a small scale, but it's like, what just happened? Like
that's like opening a browser and loading one page usually. That's crazy. Wow.
It was so fast. Well, Playwright also uses Chromium, WebKit, and Firefox. Like the browser projects rather than like full blown like Google Chrome or stuff. So there's a little bit speed up there. They're fully headless, but anyway, still nevertheless, like boom. So
awesome.
And you're getting all my spicy takes today.
Yes, we have one last question from Serene.
I can add to that. I shared a benchmark about Cypress and Playwright, so you can see that Playwright is way more faster than Cypress. And also to respond to Christina's question, I think that Screenplay and Playwright are complementary, but for now, I think we don't have neither Serenity or Boa Constrictor have this extra thing to do it with the Playwright. So it's the Playwright, it's something very low level, and Boa Constrictor is writing your scripts and everything in a nice way with the nice interactions and actors and everything. It's somehow complementary. So yeah, that's what I wanted to add. Thanks, Andy, for all the information. You are really a panda of automation.
Thank you. Thank you.
The highest of pandas. Yes.
Oh my gosh. Wow.
All right. Thank you very much. I think it's time to wrap it up. Thank you very much for joining the last continuous testing meetup of this year. We don't have anything planned for next year, but just stay tuned. You can join the Slack channel if you feel like it by going to the continuous testing website, continuoustesting.com, or just staying updated on the meetup page. Thanks again, everyone. Thanks, Andy. Also, thanks, Diego. He had to bring his daughter to bed. So greetings again from him. And thanks, everyone. Have a nice evening. Bye.
Vielen Dank.
Thank you.
Wiedersehen.
Wiedersehen.